Hello, this is Tyler Beamer, math instructor, Haywood Community College. This is an instructional math video for DMA 040. This video is in regards to Section 4, Introduction to Problem Solving. So in the past few chapters we have explored solving equations, so now we're going to look at some application problems in which we use solving equations in algebra to solve. So first thing that I want to draw your attention to here, and we've looked at this in previous sections, is some of those key words that describe math operations. So we have words that describe addition, subtraction, multiplication, division. The new column is equals, since we're looking at equations. Is a really key word. If you see the word is, that implies equals. So that's something to keep in mind, along with these other words here. Here's a general approach to solving word problems, or doing problem solving in general. Read and reread, understand the problem, highlight important information if needed. Choose the variable, so basically identify what you're solving for and then use a variable to represent that. If you can, draw a picture, something to represent the problem, some kind of image, that would be great. Then you want to translate the problem into an equation, and that's where those key words are going to come into play. So you're going to want to use those key words to do that. And then number 3 is solve the equation, which you should be pretty good at this point. So the real focus is going to be on number 2 here. And then number 4, interpret the results. Does your answer make sense? If you're solving for the height of a person and you get 782 inches, that's probably not going to make a whole lot of sense. So always ask yourself, does my answer make sense in the context of my problem? Okay. So here's an example. The product of twice a number and 3 is the same as the difference of 5 times the number and 3/4. Find the number. Okay. So the important information here, there's a lot of important information. Product, that's a key word that means multiply. Twice means multiply by 2. A number is the variable x. And 3 is the same as, that's equals, the difference, subtraction, 5 times the number and 3/4. Okay. So if we want to write that out in an equation form, we use those key words. So product of twice a number, so twice a number would be 2x. So the product of that and 3, so we're multiplying 2x and 3, so that's basically this part, is the same as, equals, the difference of 5 times the number and 3/4. So 5 times the number is 5x. Difference is subtraction, and 3/4. Okay. So that is the equation that we can write from those written words. So essentially we're translating the written words into the language of math using those key phrases. So here's what that would look like. Once again, right, looking at the key words here. Twice a number is 2x, so the product of twice a number and 3, so that's the first part of the sentence, is the same as the difference of 5 times the number and 3/4. Right? So this is the entire sentence, and then it's broken up into the sentence fragments that represent each part of the equation. So that's a nice visual. Okay. So let's look at another equation similar. So twice a number plus 3. So twice a number, remember a number is x, twice means multiplied by 2. So twice a number, that's 2x, plus 3, so plus means addition, is the same as equal sign the number x minus subtraction 6. So 2x plus 3 equals x minus 6. So that's what this sentence would be in the math language. So now we want to solve this. So this is what we've been working on, right? Solving for the variable. So once again, we want to isolate the variable, get it on one side using the inverse operation. So I'm going to subtract the x from both sides. X plus 3 equals negative 6. Then subtract 3 from both sides. X equals negative 9. So the number would be negative 9. And of course we could check that. You know, if I plug that in for x into my equation, I should get a true statement. So this is negative 18 plus 3, which is negative 15, and then negative 9 minus 6 is also negative 15. So that's a true statement. So we're good. Okay. All right. Car rental agency advertised renting a Buick Century for $24.95 per day and 29 cents per mile. So if you rent this car for 2 days, how many whole miles can you drive on a $100 budget? So let's look at translating that into an equation. So the total cost of renting the car is equal to two things: the mileage plus the per day diem that you have to pay. Okay. So the total cost needs to be $100 since that is our budget. So we're going to replace that with 100. Okay. Mileage is 29 cents per mile. All right, and the miles is what we're solving for. So miles is unknown. So we're going to let that be our variable, and we'll let that variable be x. So x is the number of miles that we drive. So the mileage cost is 29 cents per, which means multiplication, mile. And x is the number of miles. We do not know that information. That's what we're solving for. Plus the per day cost, which is $24.95 per day, and we are renting the car for 2 days, so $24.95 times 2. Okay, so now we want to solve for x, so we can simplify the $24.95 times 2, so that's $49.90. Okay, so then I want to isolate x, so I want to work with my adding, subtracting inverses. So subtract $49.90 from both sides. So we get 5010 equals 0.29x. Then we divide both sides by 0.29. So 50.1 divided by 0.29 equals 172.758, so on and so forth. Okay. So now this represents miles, and the problem says how many whole miles can you drive on a $100 budget. So let's think about this. I mean, normally we would look at this and say, well, 0.7, so that's 0.5 or higher. Well, we need to round up, right? Well, if we drive exactly 172.758 miles, then the cost would be exactly $100, and that's our budget. If I round that to 173, I'm technically going to be over budget. Not by much, maybe like a penny or two, but I will be over budget. So I want to be under budget. So then in this case, the normal rules of rounding are going to go out the window, and I'm going to round down to 172 miles, because that's the number of whole miles that I can drive and still stay within my budget. So that's kind of a tricky part about this problem, and you want to keep that in mind when you're solving it. Okay. Alright. Here's a geometry example. So the measure of a second angle of a triangle is twice the measure of the smallest. The measure of the third angle of a triangle is 3 times the measure of the smallest. Find the measures of the angle. So this is an example of a problem where you can draw a picture. We can let the picture be the triangle. We can let the smallest angle be x, since all of these sentences are in regards to the smallest angle. Right? So we let the smallest angle be x. So we let the second angle be twice the measure of the smallest. So if the smallest is x, then twice that would be 2x. And the third angle is 3 times the measure of the smallest. And once again, if the smallest is x, then the third angle is 3x. Okay. So then we can set up an equation from here, because we know that from geometry all of the angles summed together of a triangle equal 180. So the smallest angle plus the second angle plus the third angle equals 180, and then we can then solve that for x. So this will be 6x, because these are all like terms and there's a 1 there. That equals 180. Divide by 6, x equals 30. Okay. So now let's go back to our picture that we had. So that means that x is 30. That means this angle is 30. So this angle is 2 times x. Well, if x is 30, that's 2 times 30, which is 60. And this angle is 3 times x. If x is 30, that's 3 times 30, which is 90. So we're looking at a 30, 60, 90 triangle. And the way that I can check myself, if I add all of those angle measures together, it should equal 180. And it does. So, okay. Alright. So the sum of 3 consecutive even integers is 252. Find the integers. Okay, so first of all, consecutive, that means back to back to back. Even integers, right? That's like 2, 4, 6, 8, so on and so forth, right? So if we examine consecutive even integers, they go up by 2. Okay, so that's an important thing to know. So I want to find 3 consecutive even integers that add to be 252, right? Obviously, these are not the 3 that I'm looking for. Okay, so what I do is I say the first number is x. It's unknown, right? I don't know what that first number in the 3 consecutive even integer sequence is. Okay, so it's x. I do know that the next number is x plus 2, right? Because we just said that even numbers go up by 2. Okay, so if I add 2 to the previous number in the list, I'll get the next number. If I continue that, add 2 to the previous number in the list, x plus 2 is x plus 4. Right? If I add 4 from this number, that gives me to this number in the list. So this represents the expressions for the 3 consecutive even integers. So the sum of those, which means that I add them together, equals 252. So that sets up my equation. So then 3x plus 6 equals 252 when I combine the like terms. Subtract 6 from both sides. Divide by 3. I get 82. So 82 is the first number. 82 plus 2 is the next number. 82 plus 4 is the next number. And those three numbers should be consecutive even numbers, and they are. 82, 84, 86. And then when I add those three numbers together, I should get 252, and I do. Alright. So hopefully this gives you a good start into this section. If you have any questions, as always, please email me those or come by the office. Have a great day.